or sometimes we call the oxidizing and reducing. Oxidizing agent. This the oxidation and reduction. Oxidation means removal of electron. It may be partially or complete. See, the word oxidation and reduction have taken on a much broad meaning, and oxidation is now defined as the loss of one or more electrons by the substance with the element, compound, or ion. Defined as the loss of one or more electron by substance. That is called oxidation. And the reduction is the gaining of electron. Thus, the oxidation reduction or the redox reactions is any process in which the electrons are transferred from one substance to another. But this oxidation actually, it has a broad meaning and also can't give just by single line sometimes. So the oxidation, simply you can say that oxidation is the loss or partial loss of, or sometimes we call apparent loss, partial loss of electrons, or an increase in oxidation state by molecule, atom, or ion is called the oxidation. Oxidation means the loss or partial loss of. What does it mean by the partial loss? Loss means something like this. Say you have sodium, and if you need to react the sodium with chlorine, then sodium will give an electron to chlorine completely and become sodium plus and Cl minus. This is known as oxidation and reduction. Remember that this oxidation and reduction reactions are happening at the same time. Those are simultaneous processes. Now the sodium has been removed an electron, therefore sodium has been oxidized. And if this hydrogen combined with this chlorine, the electronegativity of hydrogen is +1, the 2.1, and the electronegativity of this fluorine is 4.0, then because of the high electronegativity of this fluorine, the bond electron will be attracted towards the fluorine side. Then this hydrogen has not given that electron completely to this fluorine, but partially it has been given. That is why we call that partially. The oxidation is the loss or partial loss. Partially it has been lost. If needs, it can get back. Then sodium plus chlorine will give sodium plus and Cl minus. This has been oxidized, giving an electron out. So you can simply write sodium has removed an electron to become sodium plus. Oxidation. Here partially lost the electron. Hydrogen loses electron partially. Hydrogen loses electron partially. Then the reduction, gaining no partial gain, gaining no partial gain, gaining no partial gain of electron is called the reduction. In the reduction, the oxidation state will decrease. If you have this Fe2 plus, then it can remove an electron and form this Fe3 plus. That is oxidation. In this case, if you have Cl minus Cl, then you can give an electron to that and turn that into Cl minus. Fe3 plus will give an electron and become Fe2 plus. In this case, it has been taken again. Here, if fluorine has partially taken an electron, this fluorine has taken electron partially. It is reduction. In the oxidation and reducing agents, normally agents, what they do, they facilitate. They facilitate. In this case, oxidizing agent means the one which help to oxidize. Help to oxidize. An oxidizing agent is the substance which oxidizes something else. Itself will reduce, but something else will be oxidized. Agent helps someone else to oxidize. The below example, this iron 3 oxide is the oxidizing agent. Iron 3 oxide is the oxidizing agent. Why? See, reducing agents normally oxidize itself. See, if you have a Fe2O3, here the oxidation state is +3, and you can combine that with the carbon monoxide, and the oxidation state of carbon in carbon monoxide is +2, then here you will get iron plus CO2. Iron plus CO2 carbon dioxide. In this case, you can multiply this by 2, this by 3, 3. So what happens? These 3 oxygen which were released from these is taken by this carbon. Here, this has been reduced. And this has been oxidized. Therefore, this carbon monoxide is the oxidizing agent. This is the reducing agent, right? One which is reduced itself will be the oxidizing agent which help to oxidize that carbon monoxide. So this is called the reducing agent. Sorry, oxidize. I'm sorry, I have done something wrong here. See, itself oxidizing, that means reducing agent. This is reducing agent. Why? This iron has been reduced and carbon monoxide has helped that to reduce. reducing agent itself oxidize, and oxidizing agent itself reduce. So this is the oxidizing agent. Oxidizing agent and reducing agent. See, oxidizing agent oxidizes something else while reducing itself. And reducing agent reduces something else while oxidizing itself. Opposite thing will happen. And disproportionation reaction. Disproportionation means the same chemical element will undergo oxidation and reduction. In this case, if you find the oxidation state of this chlorine, it is +5 here. Here it is -1. Here it is +7. So +5 reduces here, reduced. And here oxidized. So the same chemical element chlorine has been oxidized and reduced. So this reaction is called disproportionation reaction. Disproportionation is which the oxidizing agent and the reducing agent are the same element. And here, a disproportionation reaction is a redox reaction in which the same element is oxidized and reduced. In this case, oxygen is in -1, here it is in -2, here it is in 0. Here reduced, here oxidized. Reduce, oxidized. So the same chemical element oxygen. So that is disproportionation reaction. And the reverse of that is known as the comproportionation or synproportionation reaction. The comproportionation or synproportionation is a chemical reaction where two elements, each containing the same element but with different oxidation numbers, form a product in which the element involved in the same oxidation state. It is called maybe the opposite of this disproportionation. In this case, you can see we have lead in two different oxidation state. Here 0, here +4. But when they react, here it becomes +2 only. So this is the oxidation and this is the reduction. After oxidizing and reducing, they have reached to the same oxidation state. Same chemical element in two different oxidation states will reduce and oxidize to become the same oxidation state. So we call that the disproportionation reaction. Next one, in the case of KMnO4 and SO4, here it is in. The oxidation state +5, +7 here, +2 here. But finally it will come to that +4 oxidation state. 7 to 4, 2 to 4. Here, sulfur is in -2 and also +4. Here, sulfur is in 0. Oxidation here, reduction here. Oxidation, reduction. Then again disproportionation. Then there are some rules of finding the oxidation states. The oxidation number of an element indicates the number of electrons lost or gained or shared as of the chemical bonding. The removal of electron, then the oxidation number is assigned as the positive. Say, sodium will remove electron like this. Then sodium plus. It lost the removal of electron, then the oxidation number is assigned as positive. Now the oxidation number is +1 here. If you get a single element with charge, that means this charge is the oxidation state. Here it is +1, positive. If you lost 2, say magnesium goes to magnesium 2 plus 2 electron, then as it lost 2 electron, the oxidation state is +2. Normally we write down the oxidation state in a square bracket. Then if gained electron, the oxidation number is minus. Say Cl plus electron goes to Cl minus. The oxidation state is -1. And oxygen plus 2 electron, oxygen 2 minus, the oxidation state is now -2. In the case of monoatomic ions, the charge on the ion is the oxidation state. Sodium plus, potassium plus, hydrogen plus, the oxidation state is +1. If you get this Mg2 plus, then Fe2 plus, then the oxidation state +2. Fe3 plus, aluminium 3 plus, then the oxidation state is +3. Then rule 4 is assigning the oxidation state. If you get that the unbounded elements or bonded with identical atoms, then oxidation state is defined as zero. The oxidation of the atoms in any free means uncombined, then or they include this polyatomic ion. Is bonded with this identical. So if we have sodium, magnesium, aluminium, fluorine, nitrogen, then we don't have any charge on that, so it is not combined with anything. And sometimes if you write down N2, F2, Cl2, Br2, P4, S8, in all these cases, the oxidation state is zero. Next one, in covalent bonding, this metallic atom are assigned as the negative oxidation state with the compound and the polyatomic ion. See the covalent compound, the less metallic atoms. Less metallic means more electronegative. The oxidation state is assigned as minus. See, if we have hydrogen and chlorine, carbon and oxygen, this is -2, this is +2. This is -1, this is +1. If Cn, nitrogen, 3.0, more electronegative, therefore -3. This is minus plus +2. And we have already done these things, so this will be +1 or just plus. There may be some cases with the oxidation number of the atom is 0 even when it is combined. So OCH, in this case, hydrogen is +1. This is 0. This is -2. -2 plus 2 into 2, so +1 into 2 now becomes 0. Alkali metal will always show the +1 oxidation state because once they remove an electron from its outermost shell, it becomes the more stable configuration. So it will be so sodium, potassium plus, rubidium, and cesium. They will always form that oxidation states and become +1. Alkaline earth metals always show this +2 oxidation state. Again, because once they remove 2 electron, become a stable configuration. So Mg +2, calcium +2, strontium plus 2 and barium plus 2. The oxidation state is plus 2. The sum of the oxidation numbers of all atoms in compound is 0. Sum of the oxidation numbers of all atoms in compound is 0. See here, if we have HCl, this is plus 1, this is minus 1. So the sum is 0. Here, if you get that the KMNO4, here plus 1, here plus 7, here minus 2 into 4, altogether 0. Sum is 0. If you get that the Na2S2O3, here plus 1 into 2, minus 2 into 2, or no? Here, I'll just put that plus 4. Minus 2 into 3 equal 0. Sum has to be 0. In polyatomic ion, the sum of the oxidation numbers of the constituents atom is equal to the charge on the atom. If you get that the CO3 2 minus, this is plus 4, this is minus 2 into 3 equals minus 2. Or if you don't know this, if you just put that x even, you will find this x. If we have CR2O7 2 minus, if 1 is x, then 2x minus 2 into 7 equals minus 2. Oh, this is actually the plus 6. Then plus 6 into 2 minus 14 equals minus 2. Let's see. That's then the oxidation number of an element in a simple ion is equal to the charge on ion. I have already given that sodium plus, magnesium 2 plus, and aluminium 3 plus. In this case, plus 1 plus 2 plus 3. Like that. Then the oxidation numbers of halogen, bit different. Means it has a wide range. In the case of fluorine, the oxidation numbers is always minus 1. Why? That is the most electronegative element, and nothing can get an electron from this fluorine because the fluorine is the most electronegative. Electronegativity is the relative ability to attract bond electron. As this fluorine is the most electronegative, no more electron can take an electron from this fluorine, so it is always minus 1. So fluorine maybe in HF, maybe in OF2, maybe in NaF, no matter wherever it is, the oxidation state of this fluorine is minus 1. Next one, chlorine, bromine, iodine may have the oxidation state minus 1, 0, plus 1, plus 3, plus 5, plus 7. Even other even numbers may also possible. This NaF, I can't write down all, but I just want to say here NaBr and also NaI minus 1. 0, Cl2Br2I2 plus 1, ClO minus BrO minus NaOI. This is unstable, but here you can just write down plus R. Plus 3, ClO3 minus, right? And Cl2 minus HbRO2, like that. Then plus 5 will be ClO3 minus HClO3 plus 7 HClO4 or ClO4 minus ion. Minus 1 will be HCl NaBr. The range numbers of this hydrogen. When hydrogen bonded with metal, always minus 1. When bonded with non-metal, always plus 1. Like this. NaH, MgH2, AlH3. The oxidation number of hydrogen is minus 1. And when this bonded with non-metal like HCl, H2S, H2SO4, oxidation of this hydrogen is plus 1. Then oxidation numbers of oxygen, that also very important. Usually the oxidation state is minus 2, like this. In the case of water, it is minus 2, Na2O, MgO. The oxidation state is minus 2. Oxygen has an oxidation number minus 1 in peroxide, like this. Na2O2, H2O2, BaO2. In this case, oxygen may be in minus 1 because when oxygen bonded with identical atom, we can't assign any oxidation state. But because of the negative charges, oxygen will get -1. So each oxygen will be in -1 oxidation state. Then oxygen has an oxidation number -12. Actually, this is only a calculated value, but actually it is like this. If you just calculate, you will get it as. But actually, this oxygen will be like this. So this is in zero oxidation state. This is in -1 oxidation state. This is a calculated value and it is wrong. Why? Electron cannot be further divided into small particles. That's why it cannot have -12. It's just a calculated value. Next one. When oxygen combined with this fluorine, the oxidation number is +2. Why? This oxygen, fluorine, fluorine. Fluorine is in -1, -1. Why it is -1? And this will be +2. Because the electronegativity here is a 4.0, here 4.0, oxygen is 3.5. So this electronegative element will get the plus charge for each bond. And if you get this one, O2F2, in this case it is +1. Oxygen is in +1 oxidation state.